Okay, thank you. So, hi all, good afternoon. This is Kavin Arvind. I'm working in Cognizant Technology Solutions as a senior performance architect. I involve in performance engineering, resilience testing, observability, and SR related activities in Cognizant. So, today I'm going to walk through observability frameworks that can be used for performance engineering, in which we'll be discussing about what is full stack observability and how we enable observability for our applications, what is instrumentation telemetry, what are the different tools available in market to leverage observability, and what are the different frameworks that we are suggesting for cloud and on-premise infrastructure to embed observability in our monitoring. So this will be the high-level agenda for today's talk, and let me start with the presentation. Okay. So to start with, what is full stack observability? So if we take in infrastructure now, or like if we take in application now, the infrastructure will be like comprising of complex and hybrid services. So the microservices, they will be like hosted in a serverless environment, or they'll be running as containers, or they'll be running in compute services like EC2, or in Google Cloud, they'll be running in Google Compute Engine. So like that, the infrastructures are getting complex and more diverse. So it is very critical to understand and observe the services that are running in this infrastructure to analyze or pinpoint any issues as why it is happening, where it is happening. So, observability is a specific use case for dev and SRE teams to debug the applications with respect to production issues with the high fidelity data collected through observability. So, to enable observability, we need to have collect telemetry data. So, the metrics, logs, events, traces from the key pillars of telemetry data that we'll be like discussing over the next slides. So, you can ask what is the difference between the metrics collected by APM tool and why we need specific observability tools. So the APM tools, they collect the key metrics, key performance metrics, and other monitoring data that is collected through the APM agents. And now the APM tools are getting leveraged with observability features to enable deep dive analysis into distributed traces, logs, metrics, and even RAM metrics and real-time monitoring metrics, along with some AI-driven analysis and even AOps, so which enables us to do infrastructure monitoring, digital experience monitoring, and serverless monitoring very easier. So a full stack observability can be defined as the ability to monitor the entire IT stack in which the application services are running with the use of metrics, logs, traces, and spans to do analytics in real time. So after this brief introduction about observability, so how we are going to achieve observability? So we have to do instrumentation to get telemetry data. Instrumentation means the process of collecting the metrics from the application to do the analysis and to do the telemetry data collection. So that is called instrumentation. So instrumentation can be of two approaches. Like it can be an outside-in approach or inside-out approach. In an outside-in approach, so all the data or all the instrumented data and the telemetry data will be collected through the APM agent that is running outside the application code. If you take any APM tool like New Relic or Dynatrace, the agents run outside of the application code and they'll be installed in the servers which connects all the APM data. So this kind of approach is called as an outside in APM implementation. Whereas there's another approach for collecting customized data in which, whether the use of APM tools, we can use open source tools and we can use open telemetry, which is standard for observability, which enables us to implement open telemetry frameworks through custom codes and custom zip files. So for to enable this, we have to customize the application code with respect to these files. So application is sending data to these external tools. So this is called the inside-out approach of instrumentation. So based on these two approaches, let's see what are the different tools available in market and what are the different frameworks possible to implement observability for applications. So coming to metrics, that commonly available tools are Prometheus and Instana, Wayfront, Grafana, along with Dynatrace, Neuralink, Datadog, and Splunk APM tools. So all these tools helps us to collect the different application and infrastructure metrics from the application's hosting environment to visualize and monitor on the front end. With respect to tracing, say if we have multiple components or multiple services in our application, and if the flow of the application service from one infra to another infra, it's flowing through multiple places in the infrastructure, then we need distributed tracing, which helps us to find where we can see the application flow. So there are open source tools like AGAP and even Zipkin that is available to do distributed tracing. Whereas when we come to enterprise tools, all the APM tools and even AWS X-Ray allows to do tracing. Coming to logs, we need to debug any errors that are occurring in the application. So for that, we can use either CloudWatch logs if it is hosted in AWS, whereas open source tools like Graylog and Fluid are other options to enable logging. So coming to AWS specific observability stack, AWS is giving lots of services to do observability instrumentation. It is giving AWS container insights and Lambda insights to get all the metrics from serverless infrastructure, and it's giving AWS extra for tracing and CloudWatch logs and metrics for metrics and logs respectively. So coming to the different strategies in which observability is engineered. So there are three ways, either through APM tools, the second one is cloud native tools, and the third one is using open source software. So, whatever the APM implementation that is did through Neuralink or Dynatrace or Splunk, they all comes under APM implementation. Whereas all the implementation that is did through the cloud native services like CloudWatch or X-Ray, or in case of Stack Driver for Google Cloud. So, if you use the built-in services by the cloud provider, then it's going to be cloud native approach. Whereas if you're going to avoid both APM tools and built-in cloud solutions, and we're going to use only open source tools like Prometheus or Signas or Agar, then it's going to be an open source software strategy. So these three are the basic classifications in which observability can be engineered across applications. Okay. Now we'll see three different frameworks using these three strategies in which we can adopt these if our application services are hosted in a particular environment. Um, Coming to the first approach, so the enterprise observability approach using API. So in this approach, the application is instrumented with OpenTelemetry APIs and SDKs, which is provided by the APM tool provider itself. For example, Neuralink and Dynatrace, they can give their own agents which implements OpenTelemetry inside them, and the OpenTelemetry character which is available inside the APM agent, it will collect the data from the microservices, SHAB infra, Kubernetes, or any other managed DBs that is available. And that open telemetry connector will pass the telemetry data that is coming from the application, and it will be pushed to the observability front ends, which is again the APM tool here. So this enables us to do application performance management, database monitoring, synthetic monitoring, real user monitoring, and even server monitoring all together in a single place. So this is the most commonly adopted approach in which the APM tool takes care of all our observability needs. The second approach is using built-in cloud native and managed services, in which we can use either Amazon CloudWatch or AWS X-Ray, or even the distro for OpenTelemetry, AWS managed service or Prometheus, and Grafana. So these five are the cloud native services provided by AWS, which works in a receive process export pipeline. So basically how it works is, This pipeline contains four elements like receivers, processors, exporters, and service. So the receivers, they collect the telemetry data from the application when they are deployed into the application. So AWS has a AWS Open Telemetry agent, which automatically installs the Open Telemetry collector through code in the different services hosted in AWS where our application is running, and it is processed through processors, and it will be exported to the front ends like AWS distributed service for OpenTelemetry, Prometheus, and Grafana. So these three are the front ends in which the collected data is exported and available for our analysis. The third approach is using open source software and custom services, in which the entire observability stack is built using multiple open source softwares. If you say take the AWS infrastructure that is present here, uh, so we are adopting a common observability approach called Open Telemetry. This is the observability standard by the Cloud Native Foundation, and here we are using different softwares for collecting different telemetry data. For example, Prometheus is going to be for metrics, Signals is going to be for traces, logs are going to be for logs, logs are going to be for logs. We are also going to use Catchpoint and Pingdom for doing synthetic monitoring and API monitoring, where and also we can use Uptime to do SLA monitoring, which allows us to track the uptime and any downtimes as well. So we are also using Grafana to pull the metrics from Prometheus and visualize, and we are also going to use Alert Manager and Page Editor for alerting and paging stuff. So like this, uh, these are the different areas where we need to implement open source tools, and the selection of open source tools can vary based on the product teams and also the application teams requirement. For example, instead of signals, we can use either Aegir or Zipkin for tracing. Instead of logs, we can use Fluentend or anything else for logs. Like that, the selection of tools may vary, but the approach is same. So these tools are also used to do synthetic monitoring, whereas the metrics logs traces are connected to different services can be used for the other analysis. So in a similar way, apart from performance testing, even for resilience testing and customer experience testing, observability plays a very crucial role. And we'll see how we'll implement observability for a resilience testing. So resilience testing, as you may know, this is a kind of new testing in which we inject failures into the infrastructure to see how it is working. So basically, hardware failures like CPU stress, memory stress, or network failures like network delay will be injected into AWS infrastructure. And during the time, we need to make sure our application and infrastructure is highly observable to observe the impacts. So basically, how it works is the performance testing suite, which will inject the load into the application, will be running in parallel, and there will be custom services in AWS available to inject the failures. Okay, so AWS FIS is a solution which allows to inject failures into AWS, and during this time, the metrics from our load testing tool, either it will be JMeter or Loaderner, and also the metrics from Cloud AWS, will be both fed into Grafana and also to CloudWatch, and the entire monitoring and debugging will be taken care of the Grafana and CloudWatch side. So the metrics that we'll be watching during this are like mean time to recover, mean time to detect, turnaround time, traffic latency, error rate, and such, which are the golden signals of observability. In the same way, for customer experience testing, which is a UI profiling, in which we measure how the application is performing in the front end, in the view of a user. So here also the application is instrumented to collect RAM metrics, which are the real user monitoring metrics like last vision change, fully loaded time, first contextual paint, largest contextual paint, total blocking time, speed index. So these kind of metrics will be captured using the pushed metrics from our load testing tool and our AI profiling tool, like site speed, and these metrics will be pushed to Grafana, which will be read by the fed into Graphite, which will be read by Grafana for our analysis. So, as you can see, observability is not something new. It's similar to the same application performance monitoring that we were doing for a long time traditionally. And the key takeaways here are observability is something helps us to identify why something is happening, and we get actionable insights of fixing that. Whereas monitoring conveys what is happening, it shows something if something is red, but it don't show where the areas are red. So monitoring mostly revolves around the collection of metrics and logs, whereas observability drills further into the state through instrumentation, either through manual or automatic instrumentation. And monitoring is a key task for IT ops team and DevOps teams, whereas observability is more focused for devs, SREs, and performance engineers. And the dashboards and metrics are the critical components of APM tool, in which we can see what is happening if all the health systems are in green from those dashboards. So whereas for observability, we do not even see whether it's red or green, but we further drill into see technical details that is needed for us and also the awareness teams to find what are the reactive approaches we can take to fix any issues. So, if you see the hierarchy here, so monitoring can be helpful for doing alerting and getting an overview of what is happening, whereas we have to further implement observability to do debug, to profile, and to analyze the dependency and anticipate how the application will be working in the future. So hence, these slides highlights the uh, criticality of observability and why observability is needed for performance engineering, and also the different frameworks that we can adopt to implement observability in our applications.